All right. So a lot of people have been asking about the proof of the claim that I wrote on my status. So it's actually quite a simple, there's quite a simple explanation behind it. So I'm sure anyone can understand this, even if you have never taken like mathematics at like university level or something like that. So the idea that you use to prove this is something called the pigeonhole principle. So the idea behind it is intuitive. So it's that, imagine that you have pigeons, right? Or any birds for that matter. But you have pigeons in this case, and then you have pigeonholes. But if the number of pigeons, right? So this is a set containing pigeons, right? But if the number of pigeons is less than the number of pigeonholes, so let's say these are pigeonholes, right? These are pigeons, these are pigeonholes. But we have, in this case, 2 pigeons and we have 3 pigeonholes. But we say all of our pigeons fly into the pigeonholes. Then in that case, what happens is we can be sure that, at least one pigeonhole is not occupied by any pigeon. Because this is either what's going to happen, right? Then we have one pigeonhole that's not occupied by a pigeon, or what's going to happen is that in either case there's going to be, in this case, 2 pigeonholes without pigeons. So what we can be sure of, if the number of pigeons is less than the number of pigeonholes, then there'll be at least one pigeonhole with no pigeons, right? That's easy enough to understand. But then the other case is if we have more pigeons than pigeonholes. Now this is the interesting case. This is the case that we're going to use to prove this. So imagine a case where we have more pigeons than pigeonholes. More pigeons than pigeonholes. So for an example, here we have 3 pigeonholes. Sorry, we have three pigeons and 2 pigeonholes. 3 pigeons, 2 pigeonholes. Then in that case, we say all our pigeons fly into the pigeonholes. But then the thing that's going to happen here, we are sure that at least there's a pigeonhole with at least 2 pigeons. It has to be that way. So imagine you have 3 pigeons, right? They belong in the set A, and then pigeonholes, they belong in that set B. So what's going to happen is we said all our pigeons, 3, fly into the pigeonholes. So either that's going to happen, in which case all our pigeons fly into the pigeonholes. So we must have that. So if we do have this, then our claim remains true, that there's a pigeonhole with at least 2 pigeons. This is the pigeonhole in this case. It has to have 2 pigeons, right? Or if that didn't happen, then we would have something like that. In either case, there's going to be a pigeonhole with at least 2 pigeons. That's the claim that we're making, and you have to make sure that you understand why that is, so that we can move on to the next part of the proof. But the claim we're making is if the number of pigeons is greater than the number of pigeonholes, and all our pigeons fly into the pigeonholes, then there is going to be a pigeonhole with at least 2 pigeons. That's intuitive. But now to come and make this, to come and prove this claim that we made about, that in South Africa there are at least 2 people with the same number of hairs on their heads, you have to utilize 2 facts. The first fact is, the population of South Africa is more than, say, 50 million, right? I checked that on Google, and it says the population in South Africa is like 58 point something million. But at least we can claim that, population in South Africa is more than 50 million. We can make that claim. Facts. Number 2, we know that the average number of hairs on an average person's head is around 100,000. There isn't anyone that's a biological fact, there isn't anyone with more than 1 million hairs on their head. So the number of hairs on a person's head is at most, or let's say is less than 1 million. 6 zeros, 1 million. So there are at least 50 million people in South Africa. The number of hairs on an average person's head is less than 1 million. Two facts. Make sure you understand those two facts. We are going to use those two facts to prove this claim. So we're going to say, okay, set A is a set that contains all South Africans. So this is a set that contains at least 50 million elements, because this is the number of people in South Africa, and we said the number of people in South Africa are at least 50 million. That's true. We have the one South African, second South African, third South African, and so on, up until 58 point something million South African. And then we have here another set containing 0, 1, 2, 3 up to 1 million. Now this set is the set that contains the number of hairs possible in a person's head, right? So we know that there's no person with the number of hairs on their head less than 0, and there's no person with the number of hairs on their head greater than 1 million. That was fact 2, and this set here relies on fact 1. Now if we were to map these people to these number of hairs, and we try to recall from the pigeonhole principle, this set has fewer elements than that set. Now just try to imagine that set as being the number of pigeons, and that set as being the number of pigeonholes. So what's going to happen is you have these pigeons flying into those pigeonholes. And if you recall from the pigeonhole principle, there is going to be at least one pigeonhole, with at least 2 pigeons. But if you try to think of it in this context, this means that there is going to be a number of hairs X, that belongs to at least 2 people. And if you let that sink in, then you realize that we've just rationalized our way into the proof for this thing. Of course, you can write it in more mathsy notation and all of that, but the logic stays the same. I hope that makes sense. Cheers.